Now let's discuss about the difference between C and embedded C. Though C and embedded C appear different and are used in different contexts, they have more similarities than the differences. The most of the constructs are same and the difference lies in their applications. C is used for desktop computers while embedded C is for microcontroller based applications. C has a luxury to use resources of desktop PC like memory, OS, etc. While programming on desktop systems, we need not bother about memory. However, embedded C has to use with the limited resources like RAM, ROM and input-output ports on embedded processor. Thus, the program code must fit into available program memory. If code exceeds the limit, the system is likely to crash. Compiler for C typically generate OS dependent executables file. Embedded C require compilers to create the files to be downloaded to the microcontroller or microprocessor where it needs to run. Embedded systems often have the real-time constraint, which is usually not there with desktop computer applications. So, what basically is the different while programming with embedded C is the mindset. For embedded applications, we need to optimally use the resources, make the program code efficient, and satisfy the real-time constraint if any. All this is done using the basic construct, syntax, and the function libraries of C. Now let's see the working of embedded C compiler. Source code file, it contains the source program to be compiled. The source code is usually developed in C. Embedded C compiler generates a series of output files during compilation. Preprocessor work on .c file and generate .i file. This file contains source text as expanded by preprocessor. All macros are expanded and all comments are deleted. Compiler work on .i file and generate .src file. This file is an assembly source file. Assembler convert assembly file to .obj file. .obj file contains relocatable object code. These files are used to link with other .obj files and library by linker to generate an .abs file, absolute object file. OH converter, that is object code to hex converter, generates .hex file. This file is the binary file used to program the processor. Let's quickly see the memory organization of 8051 microcontroller. Just to get an idea what is RAM and how the variables are stored in RAM. 8051 microcontroller contains 128 byte of RAM, range from 00H to 7FH. First 32 byte are reserved for register bank and stack. Then next 16 byte are reserved for bit addressable read-write memory. And then 80 bytes from 30H to 7FH is reserved for read-write storage, or also called as scratchpad. Global variables are stored into this memory area, while the local variables get stored into either register or stack, this memory area. 8051 microcontroller got 4 kilobyte of ROM, stand for read-only memory. Starting from address 000h to 0FFFH. Read-only memory is also called as a code memory because the code written under void main function and any other function gets stored into these memory locations. Similar to 8051 microcontroller, every other microcontroller or microprocessor got two memories. One is RAM, random access memory, and other one is ROM, read-only memory. RAM normally used to store variable data and ROM are normally used to store code. Program variables int xyz. Using this statement, we are creating three variables xyz which is of type int. Character AB, this statement will create two variables a and b which is of type char. Space for variables may be allocated in register, RAM or ROM. If we write like this int x equals to 5, in that case that particular variable will get stored to ROM memory location. There are two types of variables, automatic and static. Normally automatic variables get stored into registers and static variable gets stored into RAM. Let's discuss about automatic variable. Automatic variables we declare within function or procedure. This variable is visible only within that function. Space for this variable is allocated on system stack when the procedure is entered and deallocated to reuse when the procedure is exited. If only one or two variables are used in program, then the compiler may allocate them to register within that procedure instead of allocating memory. The value of automatic variables are not retained between procedure calls. Here is the example int I, j. Here I and j both are automatic variables. The visibility of these variables are limited to this function only. So when you exit from this function, the value of I and j become 0. So every time you entered into this function, you have to initialize the value of I and j. Static variables. Static variable retain the value for use throughout the program in RAM location. We can declare static variables within or outside the function. If we declare static variable outside the function, the variable becomes global in scope, that is, known to all functions of program. For such variable declaration, we use normal declarations. Here is the example int count. If we declare static variable within function, then we have to use static keyword before the variable definition. This variable is local in scope, that is known only within the function. Here is the example static int count. Here is the code that explains the initialization of global variable count. Here we haven't used static keyword since this variable is inside the void main loop, hence we don't need to write static in front of int. Here is the another piece of code where this function is not the void main function or the main function. Here we have declared variable j as static int. Since we want to make this variable j to get stored into fixed RAM location, I have to use here word static. Hi and welcome back. In this video I will tell you about C control structures. C control structures are used to control the order in which the instructions get executed. There are mainly two execution types, conditional execution and iterative execution. In conditional execution, the statement is executed if some condition is met, or we can select one set of statement to be executed from several options depend upon one or more conditions. In iterative execution, we repeat the execution of set of statements a specified number of times or until some condition is met or while some condition is true. Let's start with if-then structure. In this structure, we execute a set of statements if and only if some condition is met. For example, if A is less than B. If this condition is true, then only the statement 1 and statement 2 will get executed. If this condition is false, the statement 1 and 2 will not get executed. Here, for comparison, we have used less than operator. In place of this less than operator, we can use other operator like equal to, not equal to, less than equal to, greater than equal to, any non-zero value, 1 or 0. Any non-zero value will consider as a true, 1 is also considered as a true and 0 is considered as false. To combine one or more conditions, we can use Boolean operators. Double ampersand is a AND operator and Boolean operator. Double vertical lines or Boolean operator. Here is the example. If n is greater than 1 and n is less than 5. When these both conditions become true, then only the entire condition become true and if statement get executed. In this example, if either of these condition is true, if statement will get executed. Please note that double ampersand and double vertical line are the Boolean operators and not a bitwise operators. Bitwise operator will write like this: single and single vertical line. Here also you note that double equal to sign is a relational operator, whereas single equal to sign is a assignment operator. Okay, now let's quickly look at if then else structure. In if then else structure execute one set of statement if the condition is met and an alternate set if the condition is not met. For example, if a equals to 0, then the statement 1 and 2 will get executed, else the statement 3 and 4 will get executed. What if we want more condition to be tested? In that case, you can use nested if else statement. For example, if n equals to 1, then statement 1 will get executed. Else if n equals to 2, if this condition is true, then statement 2 get executed. If n equals to 3, then this statement is executed. If not 1, 2 or 3, then statement 4 will get executed. Switch statement. Switch statement is a compact alternative to else if structure for multi-way decision that tests one variable or expression for number of constant values. Here is the example. If the value of n is 0, statement 1 get executed. If the value of n is 1, statement 2 value. If the value of n is 2, then statement 3. Else, this by default, statement 4 will get executed. Now let's see iterative C control structures. First one is while loop structure. Here we repeat a set of statements as long as some condition is met. For example, while a is less than b. Till the time this condition is true, statement 1 and 2 will get executed continuously since it's in a loop. When this condition will become false, the while loop will get terminated. Do while loop structure. Here we repeat a set of statements until some condition is met. Here is the example. You can see here while condition is tested after do statement. Since the condition is tested after the execution of set of statements, so the statement are guaranteed to be executed at least 1. So first statement 1 and 2 will get executed and then we will check for while condition. Now if this condition is true, then again statement 1 and 2 will get executed. Do while loop guaranteed that the statement 1 and 2 will get executed at least once, since the while condition is getting checked after do statement. For loop structure. For loop is a more compact form of while loop structure. Here is the example. For m equals to 0, m is less than 200, m plus plus. This condition is what we call initialization. This is what we call condition for execution, and this one is operation at the end of each loop. Initially the value of m is 0. Since value of m is less than 200, the statement 1 and 2 will get executed, and then the value in m will get incremented by 1. So this loop will iterate 200 times. Here is the example. We normally use for loop statement in embedded C to generate time delay. For I equals to 0, I is less than 100, I plus plus. This one form the outer loop. Then there is one more loop for j equals to 0, j is less than 1000, then j plus plus. This forms the inner loop. We do not write anything in this loop. Hence, we created delay. Now the question is how delay get created. This loop will get iterate 1000 times, and this loop will iterate 100 times. Means both loop will get combinedly iterated for 1000 multiplied by 100, this many number of times. Since this is the process that will get executed 1000 multiplied by 100 times, it will consume some time, and that is how we generate delay.